We good to go?
Yes.
Okay. There we go. Nice and stressful position to find yourself in to be the first talk of the day. Yeah, so hello, welcome to everyone in the room, welcome to the internet. Hello, internet. This is a talk about Spelunky, and specifically Spelunky as a use for artificial intelligence research. A quick overview and introduction of myself, including me with coffee, which right now is the most valuable commodity on earth. My name is Thompson. I'm a lecturer in computer science based at the University of Derby. While I am based in Derby, the reason that coffee is really valuable to me is I'm just back from giving a couple of talks at an AI research conference overseas. I've been back in the UK 12 hours and 16 minutes, and I'm running on about 3 hours sleep. So if I fall asleep in the middle of the talk, I do apologise, give me a shake. Or tweet me, whichever one's faster. So a quick overview about why I'm here and what I do. Well, I'm an AI researcher, and I've got a real particular interest in computational intelligence algorithms, which are a form of AI systems which try to learn over time. And I've spent much of my academic career, like I say, I'm a lecturer at present. I have a PhD in artificial intelligence and a master's background in AI as well, computer science undergraduate and the like. But I've spent much of my academic career looking at AI applications within games. And the reasons for that are twofold. One, I'll explain that later on in the presentation, but the other one really is that at the end of the day, if you're going to try and build Skynet and destroy the world, you should at least try and enjoy yourself along the way. And so this is kind of the quick overview of our talk, the 90-second obligatory Spelunky overview, and then also talking about how this then applies to AI, why Spelunky in particular, and some of the work that we've been doing of late. So 90 seconds I'm assuming is the upper bound, because I'm always interested to see how many people actually know the game or play the game. So in this, of all communities, how many people are familiar with or have, in fact, actually played Spelunky? And I get a show of hands. This is the best turnout I've ever had. I swear, I go to AI conferences and there's like 3 people in the room who go, I think? Is that? No, that's Spelunker. Sorry. Some of our communities got a little bit more grey hair than I do. But yeah, so Spelunky, it's a platformer game which adopts an awful lot of roguelike elements. It came out in 2009, originally developed by Derek Yu in Game Maker, and was then subsequently ported onto every platform imaginable, unless, of course, you happen to like Nintendo systems. Please make a version on the 3DS, for the love of God. I don't want to buy a Vita just so I can play Spelunky on the go. But yeah, it's a really interesting game, it's a really fun little game, and I think an awful lot of roguelike elements are what bring people back to continue to play it, because it adopts an awful lot of similar mechanics from the likes of Mario and stuff like that, but I think it wraps it up in a far more interesting and engaging package. So, what about something in particular, this Spelunky and AI benchmarking, and also this project we started doing called SpelunkBots. Now, SpelunkBots is an API that we've built into the original Game Maker version of Spelunky, and it was largely developed originally in its first pass by Daniel Scales, who was a former student of mine, and now there's a small army of people that are working with me to try and develop this. We've written this interface in both Game Maker language but also in C++, and the idea is that you effectively strip the human out of it and you then write code that executes in your place. So the idea is, we want to write an AI system that can actually play the game. Now, why on earth would you do that? Well, we've got a real thing, particularly in the artificial intelligence community, about benchmarking. AI communities in particular love to try and find benchmarks. And if you go into different pockets of AI research, you find that we've got different benchmarks for different purposes. One of the main reasons for this is it provides this focal point for us to discuss ideas. Because we're notorious for working on our own little pet projects, which are very rarely a reflection of the real world, or rarely a reflection of that which we're trying to solve. Or I'm really interested in doing AI for logistics. Okay, so what, are you working on a real world logistics problem? No, but I've got this awesome toy domain that I'm great at solving. Which isn't really a reflection of anything, really. And this all sort of kicked off about 10 odd years ago when there was a group of academics in the late 90s, early 2000s who started looking at Pac-Man. And they said, oh, we'd love, games would be a great place to exploit and explore AI algorithms and trying to enhance them. And so they started saying they were working on Pac-Man. And I say Pac-Man in this case. It was games that approximated Pac-Man in the sense that there was a maze and there was some things to collect and there was something chasing you, and they gradually became more and more Pac-Man-esque, but this ran for about 6 or 7 years. And eventually what happened was a team in Essex turned around and said, no, let's actually make an AI API that links with, and this was actually a Windows build of Ms. Pac-Man, where what they wrote was the screen scraper software. So the only way you could actually access information about the game is this system would look at the game window and tell you this is all the information that's available to you, and then their code would then interface to actually then drive the titular character around. Excuse me. Now, we've actually been doing this a lot over the years. Ms. Pac-Man kind of helped kickstart this, but I would argue the most famous example was Super Mario Brothers, which ran from 2009 to 2012 before Nintendo sent a cease and desist. Because, well, it was getting rather popular, and it's based on the Infinite Mario Brothers clone, which was developed by Notch, who we might remember as being somebody who made something slightly more famous. And, well, he certainly didn't make any money off of the back of that. But we've also looked at other problem domains. Unreal Tournament used to be explored in what was called the 2K Bot Prize, which was like a Turing test, where you could write a bot that could pretend to be a human in an FPS server. And, for example, StarCraft, which is still an ongoing thing. And I was looking at Spelunky, particularly when Dan came to me. The reason this kicked off is because Dan's a big Spelunky fan. And he goes, dude, could we do something in Spelunky? And I'm like, Spelunky, that's a cave diving game, isn't it? Yeah. And I went away and played it. I'm like, oh, there's actually something to this. That there's an awful lot of really interesting attributes about this game, which subsequently translate into kind of engaging AI problems. And I'd say that it kind of fits the same criteria as a lot of the other games I've already described, but there's a lot of other things in there which I think are even more engaging, which I'll come back to in a minute. Naturally, we need to have AI that thinks on its feet. It needs to be reactive. It needs to be able to see what's going on around it, and so often Spelunky need to do that. You also need to think about the future. One of the things I love about this game is that it is non-deterministic and it's imperfect information in the sense that we never actually know where the exits are. We never know where all the gold or treasures are going to be, and we always have to kind of think on our feet as to how to actually navigate this space. But also this kind of weird multi-objective optimization, which is essentially we've got multiple things we're trying to do at once. I'm trying to find the exit, I'm trying to find gold, I'm trying to take out monsters, and I'm trying to do it quickly. So I thought, oh wow, this is actually a really cool idea, we should definitely explore this. Now, this is actually, for me, this is becoming an easier question to answer over the years, is what elements of this game are so engaging, and what particular elements of its roguelike aspects really help challenge our research interests. So in terms of why, I think from a kind of basic mechanical level, we had to try and condense this and kind of show this off, particularly to AI academics. About a year ago, I presented a paper on our first body of researching this in Dortmund last year. And Dan and I put together a little video, and hopefully the audio works so we can give it a shot. I have audio, I don't know if it's coming through, but... So yeah, long story short, Spelunky is actually really hard, and I think it's very hard for players, and then by extension that makes it very interesting as an AI problem. And I say this on the basis that I still haven't actually finished the game yet, and I really should hurry up and get round to actually figuring out how to beat the game, considering I'm going around advocating it. But looking at it as an actual scientific problem, which I've been doing recently, we've realised that it is at minimum what I would consider to be interestingly hard. Now, I realise that this is probably not the place, particularly on a Saturday morning, to start talking about computational complexity theory, and I will not go into it in a lot of detail because it makes my head hurt, and I'm supposed to be the one that knows what I'm talking about. But through an awful lot of, we've been looking at the overall mechanics of the game, and then how does that translate into an interesting problem to try and resolve in a real-time scenario. And we've discovered that it's actually in what we call the MP-hard, or at least at minimum in the realm of MP-hard computational complexity problems, which puts it up there with the Turing halting problem. Now, what this means in the grand scheme of things is that it's actually very hard, and I'd say the layman description of it is that it is very easy to prove, it's relatively easy to prove that the solution that we have by our AI system is good at what it does, but it takes us an awfully long time to actually build that solution in the first place. And I just gave a talk about this at the Foundation of Digital Games conference just earlier this week, in that we've devised that not only does this game exist in what we call P-space, which is a relatively broad area. In fact, most 2D platformers exist within the P-space bounds of computational complexity, but Spelunky in particular is at minimum in this sort of periphery as we move between MP-hard and then possibly P-space complete. That's the last time I'm going to talk about computational complexity. Long story short, it's really hard, and that's a good thing. In fact, what we've already discovered is that most interesting video games have to be at least MP-hard. For humans to find them engaging, and certainly of natural equivalence then for AI systems. Now, I think some of the more roguelike elements are actually what makes it very interesting as someone who's trying to write an AI system that can try and play that game. And first and foremost, I would probably say the two key components of most roguelike games is the notion of procedural content generation and the crafting of the physical environment, and then permadeath in the event that if you die, you have to go back and replay the whole thing from the beginning. Now, this actually proves really difficult and really challenging for an AI system because, firstly, we've actually got pretty good now, if you look at the likes of computational intelligence algorithms, machine learning such as evolutionary learning and reinforcement learning. Evolution, it evolves a good solution, and in reinforcement learning, it learns from its own mistakes and it tries to become better over time. It's like the equivalent of putting your hand in a naked flame sort of thing. Now, these algorithms are very good at what I would say is overfitting on particular problems. So if you give it one specific problem, it then becomes very good at solving that one particular problem. Now, this can be quite useful in a lot of environments where there's very little randomness. Now, this is why I'd say things like Ms. Pac-Man proved really interesting, because Pac-Man is a relatively fixed environment. The only random part of it is the ghosts. But in this case, pretty much everything's random. We don't know where the monsters are going to be, we don't know where the treasures are going to be, we don't even know where the way out is. The actual key objective that we need to try and complete, we don't actually know where that is. We need to explore this environment. Now the thing is that you can try and build a model of this world as you're going and explore it, but as soon as you die, that model's completely useless because the next time we go around to playing it, the model's going to be completely different. So what we have to start doing is thinking about generalized action policy. And we're not there yet, because I've literally just kick-started this kind of project, but what we actually need to do is develop an AI system that can, on a very implicit level, understand what the PCG system does. Now, I've found this really interesting watching like speedrunners who play Spelunky, and I think that's what they do. Perhaps they wouldn't say that explicitly and in that sense, but what they do is they build this weird internal model of how the PCG system works and they exploit that to their own benefit. And we need to figure out how to do that. And that's probably going to mean I'm going to blow several laptops and a couple of my office machines between now and for the next 3 years. But also this interesting setup of the acquisition of treasure in the game needed then to subsequently purchase items, but also the fact that this is all happening against a fixed time frame. I need to finish this level hopefully as quickly as possible. Unless of course I'm score running and I'm actually waiting for the ghost to turn up. But even then, if I'm waiting for the ghost to turn up and make this even more interesting, I have to have at least figured out where the exit is by that point, where all the treasures are, so that, for anybody who's not familiar, the ghost will turn up after about 2 minutes, and if it goes over any of the treasure, it turns it into even more valuable diamonds. So that's actually a legitimate strategy you can make, but we need to know where all these objects are so we can then lure the ghost in that direction. Now, for an AI system to focus on one of these objectives isn't that hard. I could probably write something very crude that would do it in an afternoon, but to write something that can effectively balance between these different things and recognise in certain contexts that one of them is more valuable than the other is a very, very hard problem to do. And so we haven't really kind of figured that out yet. So we've actually been doing some research in this area, and we're a long way away from finished. But we're actually now running competitions on it, and we're inviting people to participate in this purely because I'm interested to see what other people do. And this is beyond academics in this case. Anybody with any passing interest in this. And they go, well, how do you try and solve this problem? Because there's always something interesting about the human perspective that an AI can try and mine. So, first of all, we've been trying to look at AI Spelunky players. What methods would prove best? And naturally, how can we explore this physical space? One of the things that we actually did when we built the API is that it has the same limitations as a human does when you start the game. Because if we were to cheat, when you actually start the game up, we could see the entire map from scratch. Now that doesn't help because that's not really a reflection of how humans play. So we actually built a fog of war into the API, so when you start, you can literally only see this current screen that you're standing in. In order to find everything else, you have to then go out and explore the environment, and your knowledge state that the AI has grows as more of the world is actually explored. Now, to date, I know of a handful of bots that we've actually written, some using kind of basic AI methods like A-star search, which prove reasonably effective in some contexts. We can beat a myriad of levels that we handcraft in the level editor, but we've still got a long way to go in terms of playing the actual game. Some of our best bots, when you actually just drop it in, it'll maybe get about as far as that. And of course, there's the entrance there. Because there's some very particular configuration of tiles in this setup that it wasn't ready to kind of deal with, and it just sort of either jumps in there and gets killed with a fish, drops a bomb and blows itself up, or just walks into that wall for the next 2.5 minutes. One of the other things that we've been doing was actually a student of mine, James Kite, who spent his final year dissertation writing artificial neural networks, which are these kind of nonlinear data structures designed to mimic human brains. And it was running in this learning algorithm to try and see if it could come up with a small network that could figure out how to beat levels. It does a really good job in the handcrafted levels, it does terribly in the main game. Now I expected that, so this wasn't like I just when I went to mark his dissertation. In there, I've run, and how far did you get? Yeah, this is a fail. You're not getting a degree anymore, buddy. No, I didn't state it like that. Yeah, you need to get at least to the ice caves or you fail your dissertation. That would be really harsh. But we've also, in fact, a student of mine who's currently overseas and was doing an AI class in Norway, Tom Rogers, actually wrote a reinforcement learning bot and implemented an algorithm called Q-learning. Once again, it does really well in the handcrafted levels. I haven't actually seen how well it works in the main game, but of course one of the problems with the reinforcement learning algorithm is, again, we try to overfit against the solution and it's looking at the same thing again and again, because it tries to figure out through experience how to solve that one level. Of course, as soon as you die, a completely different level comes up, so we can't really do that. I think there's a lot of challenges that await us trying to explore this. There's a number of big AI algorithms at the moment which I'm dying to look into to apply to this. Anybody who's AI familiar, particularly on Twitch, Monte Carlo Research, and Rolling Horizon evolutionary algorithms. But these are actually really difficult. To explain this in a nutshell, what you do is you I'll actually do it as a human process. What you do is you say, right, I'm here. Now I'm going to walk towards you. So if I pretend that I walk forward in every possible step in this sort of 90-degree range, and I test against each of these maybe a couple of thousand times in the next 15 to 20 frames of the game, which one was the best thing to do? So I exhaust all this computational power and it goes, right, walk there, okay. Now what? Do the whole thing again. And so this is it's a very powerful algorithm. It's actually been very good at solving things like Computer Go. It's been very good at things like Ms. Pac-Man. But the thing is that this has got a very long horizon because you can't exhaust that much computational time trying to look that far in the future. So it's a very interesting problem to see how well those sorts of things work, where it's sort of you exhaust all this simulation into the forward model and kind of looking into the future, go, what happens if I do this and this? And then it's like, oh, just do that, and then you fall in a pit and a spike hits you because you didn't anticipate it. Also, I think the procedural generation and understanding how that generation works is a really interesting problem. One of the things I'm actually started to do now is I'm assessing from a level design perspective what the actual generator does, and then whether or not I can build models of understanding of that level generator. I think the next thing after that is what has happened as well in like the Mario competition, is we actually wrote our own level generators because AI PCQ research is kind of a big thing and everyone's really excited about it. Speaking as someone who actually just presented some work on Legend of Zelda dungeon generation this week on behalf of my student Becky Lavender. So it's just, there's so much to do. I could easily just build like the next 10 years of my academic career out of Spelunky. So thanks a lot to pretty much anybody involved in roguelikes that helped to kind of pioneer this front. You guys are all great. In fact, I'll take this opportunity just to plug that we're running the first ever Spelunky AI competition at the IEEE, Computer Engineering and Electronic Computing, I think, CEEC conference. It's running at the University of Essex in September of this year, and we've got a deadline of September 1st. And what people do is you just write a bot, and you try and see how far into the game that you can go. And we're actually being quite strict in the sense that we wanted to break it down into both score and time, because we were aware that how do you actually grade this? How would you actually grade a bot? And myself and the team who are working on the competition, we just sat and watched a bunch of long plays. And it's, well, look at this, we've got people who are like into the score runs, we've got people who are doing speed running. It would be unfair to punish one group and support the other. So we've offered that you can submit to one or both of those tracks. If you're interested, and you guys in here or those on the web, we're all hosted up on spelunkbots.com. We actually have ourselves on Twitter as well as spelunkbots. You should check it out. Because we're always looking for insight, feedback, and just generally harassing us for not doing something that in hindsight would actually be a really good idea. So yeah, that's me. Thanks very much. Do you have time for a couple of questions?
Yes, 5 minutes.
All right, I thought that was like either I've got 5 minutes for questions or I have 5 questions. I couldn't tell. Yes?
How do you interface these games? So do you scrape the screen or do you extract the game data?
Yeah, so in this instance we scraped the game data, but the first thing that we did was we tried to clean it up in the sense that you're only allowed access to information that you actually would see if you were a player. So we can access things like where everything is on the map, what type of objects are in the map at certain locations, but only in the event you've actually seen it. And particularly if objects are moving around and they went outside of your view, if you will, then you can't see them anymore and you have to go out and actually explore them again to find them again. It's an interesting thing that with some of these benchmarks, we only do the screen scraping approach, and in other cases we pull directly from the game. There is, I think, in some respects this can be a problem because you maybe are giving the AI an unfair advantage because it's able to pull information perhaps at a finer level of granularity than a human can. But we try to do our best to sort of level the playing field in that respect. At the same time, I think this is a hard enough problem that even if we give the AI a small advantage, I think it's probably going to need it. Yes?
So the first can say your progress from leading question
Yes, sorry. Yeah.
I'm just wondering, I've seen the Infinite Mario AI stuff before,
Yes.
and I've seen it being very advanced such that it easily beats what a human is capable of doing, the speed at which it's able to make moves. I mean, is there not a lot of stuff that you can pick up from that procedure level is permanent?
Yeah, so the question is in relation to the Super Mario AI competition, how much of that knowledge can then be kind of transferred across. Now, the interesting part about the Mario AI competition is it was solved in the first year it ran. Robin Baumgarten, who's now an indie developer, was actually an academic at Imperial College, wrote an A-star search which trounced every computationally intelligent algorithm that tried it. It's actually quite embarrassing a little bit, because if you look at all these really invested learning algorithms, we're trying to learn how to play Mario, and you just went, A-star. And it's amazing, you look at that bot, and it's absolutely fantastic. I think one of the reasons that it works so well is that you can abstract into all of Super Mario into run right, don't die. And I think one of the things that really help here is that firstly, sometimes you're going to have to run left. Sometimes you're going to have to fall. Was a point I actually made in the paper that I just put out is that in Mario you're actually on a fixed axis. You're essentially just moving one frame along this x-axis. You don't really have to worry about the y-axis at all. And you always know that the pressing issues, provided if you just keep running, are always what's in front of you. Now in Spelunky that's not necessarily the case, because sometimes you might be falling in mid-air and then you actually have to factor for something because you suddenly see something below you. Now, I think it's certainly not as easy as Mario. I think if you're actually really crafty about it, you could probably write a rather clever A-star bot. I'm interested to see whether or not it accidentally gets caught in dead ends, or it naively does something which at the time seemed like a really good idea, and then in hindsight it discovers is actually suicide. I think there's a lot of transferable knowledge there, but I think that the scope of the problem space, I mean, I could be completely wrong. I could be sitting here 6 months from now after the competition going, yeah, actually, all you need is A-star. And I've just wasted like the last year of my academic career like building up this whole competition framework, and it's like, actually, A-star, it's fine. I like to think that's not the case. In some respects, I actually love to be proven wrong.
I will say I'm actually good friends with Robin.
Oh, well, he knows I've been working on this. The last time I spoke to him, I saw him at the Norwich Gaming Festival, because I was talking about Spelunky then, but I don't know if he's heard about the competition yet. I was actually tempted to drop him a line going, yeah, you want to dish out that old A-star bot and see how far you can go? Because look at it this way, if you submitted that bot and it doesn't work, I can then stand there and go, yes, I have got the new problem for everyone to solve, because the interesting part was that, particularly with the Mario competition, after that first year, they had to break up the gameplay track into learning algorithms and A-star, so that Robin was kind of like over there. But also then that's when the level generation track occurred as well, and also the Turing track, because they then were trying to see whether or not you could write a bot that could fool people into thinking it was human, because Robin's Mario bot is godlike. It actually cheats on, I think, 2 or 3 occasions on the video that he's got on YouTube, because it knows how to wall run in the Infinite Mario clone, which it shouldn't be able to do. And it goes, nope, it falls in a gap. It goes, oh no, hang on a minute, I'm going to get back out. Oh, no.
There was something that did in Mario, not in Base Mario.
Yeah.
As I'm sure a lot of people saw, it was only about 6 months back that someone wrote an AI for NetHack, which was called NetHack for the first time. And I think one of the biggest issues that they ran into with that was getting the AI to choose when in the entire game to use items which it had only kind of finite number, like bombs and ropes and things. So I would guess for Spelunky, is that a similar kind of issue of waiting? Do I need to use a bomb now versus keeping them wait versus the kind of expectation of future bombs or not future bombs and that type of thing?
Yeah. So for Australian people, the question was related to the use of items. and the kind of overall challenge of whether or not you actually have to some sort of weighted decision process and when you use items and when you don't. I think actually what you said is entirely right in the sense that I have X amount of bombs, I have X amount of ropes, but is it prudent to use them at this? I mean, it's exactly the same problem that a human has when they play this game of, do I waste this bomb at this particular point in time? Again, you've got to then factor in how much gold you've acquired, because then if you've run out of gold, you're not going to be able to buy any more, and you can quite easily, I mean, I've done it on more than one occasion, I accidentally fall into a hole, and I've run out of ropes. I've got one bomb left, and I go, this might work, and then you kind of place the bomb in one corner, and then you kind of hop a little bit to see if it can blow up without killing you, and that comes down to bad resource management. So, and I think at present, this is one of the more interesting aspects, because when you actually look at speedrunners, or at least in my time looking at speedrunners, you very rarely see them playing the game as you typically would. They typically find a nice exploit. They figured out where the PCG is going to build the environment. They find the teleporter with some lucky, it's a probability and luck kicking in for you. They get that teleporter and then they spam it frequently to try and find the exit. Now imagine if you gave the AI the teleporter by default, it'd probably be able to do this really quickly, because it can then do this exhaustive search process of going over here, over here, over here, over here, over here, exit, done. But when it's not doing that, and of course we can't really rely on our AI to just hunt down the teleporter, it's going to have to think at every point whether or not wasting an item, potentially wasting an item to acquire more gold is a valuable thing to do, which is also called Tommy trying to play Spelunky at this stage. And you look at that one bit of gold and go, is this okay? I'm not very good at this game, I'm really not. I think that only time will tell at this stage, because we really haven't exhausted the problem space sufficiently yet, but I'm really interested to see how people try and address that particular problem.
And now we shall leave it for this one.
Awesome. Thank you.